All right, so here's the homework for tonight. Let's take a look here. So it's fill in the missing parts in the chart below. So notice here as an example, -3 is less than or equal to, because it's a closed circle, x, which is less than 5, open circle, and then -3, 5, so smallest to largest. Closed circle is a bracket, open circle is a parentheses. All right, and you can take a look at the second example, but I'm gonna go straight to the homework now. So for number 1, it says x is an element of all real numbers such that x is less than or equal to 3. So what I'm gonna do right here is I'm gonna put a number 3 here. I'm not gonna fill out the rest of the number line. If you need to, 4 and 2, so you know this goes 5, 6, 7 to infinity, 2, 1, 0 to negative infinity. All right, so equal bar, so filled in circle. And since my x is on the left side and it says x is less than or equal to, all the numbers less than or equal to 3 go to the left. And I know for me that heads towards negative infinity. All right, so from here, when I use interval notation, it's going to be the smallest number to the largest. So this arrow approaches negative infinity from the left side, so that's my smaller number. And it stops here because there's a closed circle at 3. And remember, infinity, we'll use a parentheses because we do not know that value. And 3 has a closed circle, so it's included, we show that with a bracket. All right, for number 2, they give us the interval notation. So I'm going to go ahead and graph this piece first. So I know it goes towards negative infinity. And it stops at 4, so I can just put a 4 right here. I put an open circle, and I don't fill it in because a parentheses means it's not included. And it's headed towards negative infinity, so that's to the left. And now I'm going to write my set builder notation. So braces, x such that, and wherever this line is, I always use that as x. So x, and it's all the numbers less than 4, not equal to, because it's an open circle. So x such that x is less than 4. All right, for the next one, number 3, it gives us just the graph now. So I have to figure out set builder, and I have to figure out interval notation. So for me, I just think interval notation is easier. So as I start from the left side, there's no arrow, and I have a closed circle at 2, so that's my first point. And as I continue on, there's another closed circle at 6. So notice it's smallest to largest. So 2 is smaller, and it has a closed circle, so that's a bracket. 6 is larger, that second has a closed circle, that is also a bracket. All right, now for my set builder notation, braces, x such that. So just like here, I start with 2 is less than, remember this is considered x, and x is less than 6. Now since both circles are closed, they should have equal bars. So 2 is less than or equal to x, which is less than or equal to 6. All right, for number 4, 5 to infinity. So we start at our left side, which is 5, so just put a number right here. It's a bracket, so I know it's a closed circle. And this one heads towards infinity, which is now to the right. And draw my graph, and there it is, heading towards infinity. Now for a set builder, I'm going to show you 2 ways to kind of write this. It's going to be up to you. So braces, x such that. For me, I'm always going to start with x, and I can see that x is greater than or equal to 5. But if you want to kind of keep it in the same mindset of like interval notation, when you're doing your set builder, you could do something like braces, and I'm just showing you here, you don't have to do this one, but braces, x such that. So start with the number, and remember I said this is x, and we can see that x is greater than it, and 5 is less than x. So if you want to write it like that, these are equivalent, don't forget your equal bar. These are the same thing. So it's your choice. You can write the x first or the x second. Just notice on these right here, there's never going to be infinity on set builder. The infinities are only allowed in interval notation. All right, let's move on. Number 5 gives me the graph. Okay, so I'm going to start with interval notation first. I see this arrowhead right here, and I know that heads towards negative infinity, so that's my smallest value. Parentheses, because we don't know what it is. And as I continue on the graph, it stops at 1, and that's a closed circle, so I put a bracket, and just make sure there's nothing else, and that's good right there. For my set builder, braces, x such that. So here I start with this arrow, and remember I consider this whole part right here to be x, and it is less than or equal to, because it's a closed circle, and what's less than equal to is 1. And close your braces. All right, for number 6, it gives an OR statement, and so we have to come up with a graph and interval notation. So whenever I'm given the choice, I always want to do the graph first because it's just easier for me. So first number I see is x is less than 1. So I'm treating this as two separate parts. So less than 1. So less than is an open circle, and numbers less than are 0, negative, infinity, all the way over here. And then I'm going to count to 5. So 1, 2, 3, 4, here's 5. That is a closed circle because there's an equal bar. And it says x is greater than or equal to 5, so that's every number to the right heading towards positive infinity. All right, now when I do my interval notation, since I see the word or there, I know this is going to be a union because it's broken apart. So as I start from the left, like a book, first value is at negative infinity. Parentheses. And as I continue, the first stop is at 1. Open circle, so you use parentheses. Union, because it's broken apart, it's split apart. And when I start, the next number I see is 5. And I'm going to put a bracket on there because the circle is filled in. And this one heads towards infinity. And there's my interval notation. All right, for number 7. So once again, start from the left. I see an open circle at negative 5. And hopefully by now you know that's a parentheses. And as I continue on, I have another open circle at negative 1, which is a parentheses again. And then that's it, nothing else. Okay, now for set builder. Braces, x such that. So I start at this number first, negative 5. Because as I go here, the first start is at negative 5. That is less than x, which is less than, as I continue on, I see it stops at negative 1. And now I go back, open circle, so no equal bar, open circle, so no equal bar. So my expression or my inequality is negative 5 is less than x, which is less than negative 1. All right, now for this one, x, number 8, x such that x is all real numbers. So what that means is it's the whole number line from negative infinity to positive infinity. So when I start with my interval notation, smallest number always comes first. In this case, the smallest symbol, which is negative infinity. Largest is positive infinity. And there is my interval notation. All right, on to number 9. So starting from the left, I see this arrowhead right here goes towards negative infinity. Then it stops at negative 1. Then there's a break, so I know this will be a union and an or. Starts at 2, and this heads towards infinity. So I'm just kind of marking it out so I know my intervals. So starting at negative infinity, and hopefully by now you realize that any infinity, positive or negative, has a parentheses. Comma stops at negative 1. Closed circle, so that's a bracket. Union starts back up at positive 2 with an open circle, so that's a parentheses. And it heads towards infinity. All right, for set builder, once again, there's two ways. Like if you go back up to here, you can write them both like this, but I usually tend, I'll show you what I do for these, and then I'll show you another way you can do it. It's up to you. So I do braces, x such that. So remember I said this is x, so x is less than or equal to negative 1. Or, now over here, I always do x first, so x is greater than positive 2. And close my braces. But if you don't like this, the way it's written right there, you could also say that 2 is less than, and we know this is represented by x, that interval. So they mean the same thing, because if you notice the x, it's opening towards the x, and over here it's still opening towards the x, so it's really the same thing. There's no difference. All right, number 10, 1 comma 4. So for my graph, start at 1, count 2, 3, 4. Parentheses on both of them, so open circle, it's an interval, so I connect them. All right, for my next one, braces, x such that, and when you start noticing whenever it's going to be a bounded, so it's start and stop point, smaller number, less than x, less than the larger number. Then I always go back, open circle, no equals bar, open circle, no equal bar, so we're good there. All right, on to number 11, x is greater than 7, so put a 7 here. Open circle because it's not equal to. Numbers greater than 7 head towards infinity. And for my interval notation, it's going to be from 7 to positive infinity. Smallest to largest. This is an open circle. That's parentheses. Infinity, always parentheses. All right, and last, number 12 here, negative 2 to 2. So close circle above -2 because it's got a bracket. -1, 0, 1, and 2. Close circle above that one as well. And we connect them. And now for my set builder, braces, x such that, and here, smaller number, less than x, less than bigger number. Both are closed circles, so I know this is equal bar, equal bar. All right, on to the back. So here it says, part 2, answer the following. Given the graph of f of x below, find the following. All right, so first thing it says, on what intervals of x is f of x increasing? So where does this graph from left to right go up? So I see from here to here, the graph is rising. Now remember, this is with respect to the x-axis. So on the x-axis, this goes towards -infinity. And it doesn't stop at 4. 4 is a y value. It actually stops right here, which is 0. And I always use parentheses. The only time I use brackets is if there's a starting or stopping point that it has a closed circle. All right, now the next one says, on what intervals of x is f of x positive? So I'm going to draw a line through the x-axis because this is, I'll consider it 0. It's neutral. It's not positive. It's not negative. So where is this graph positive? What this means is, where is this graph above the x-axis? Well, from here all the way to here. And now if you notice those 2 points, I put circles because it's on the x-axis, which is neutral. So from -2, comma, to +2, those parts are positive. And once again, I'm not including -2 or +2 because I have open circles, and parentheses mean that it's not included in the solution set. So every number between -2 and 2 is included to be positive above the x-axis. All right, what is f of 0? So if we talk about f of 0, we're talking about function notation. So f of x is equal to y. So they're telling us right here that x is equal to 0. So they're trying to find what's that corresponding y value. So I'm going to go where x is 0. I'm going to go down the graph, and notice I don't hit the graph, the function, but when I go up, I hit it right there at the value y equals 4. And what does this value represent for this function? Well, hopefully you see that that is the y-intercept. For the next one, it says when f of x equals 0, what does x equal? So now they're saying f of x equals 0. So they're giving us y, and they're asking us to find x now. So now I'm going to go where y is 0. And here I'm going to draw a line through and see where it hits the graph on the x-axis. So it hits right here. That's at -2. And as I continue, I see it hits here as well at +2. So notice this one has 2 solutions because it hits 0, y equals 0 here, and y equals 0 there. And the reason why y is 0 there is because these are called your x-intercepts. All right, on to number 14. On what intervals of x is f of x decreasing? So that means from left to right, where's this graph going down? So I can see it's going down from here to here, and this piece right here. So now we're gonna have a union. So remember, once again, it's with respect to x. This is headed towards -infinity. And as it comes, it stops right there at that point, -1, -2, and -3. I don't include them. Union, and then it's from x value of 0, so 0 right here, to this value is 3, and don't include either one of those. All right, now this one, on what intervals of x is f of x positive? So I'm going to draw, once again, like I did before, the x-axis. So anything below the x-axis is negative, anything above it is positive. So it looks like the whole graph is positive, but it's actually neutral at 2 points. It is neutral on the x-axis at -3, and it's neutral at +3. So take a look here. This one, make sure you do pay attention. So this heads towards -infinity on the x-axis, and it's positive. At this point, it's neutral at -3. Union, remember, -3 with a parentheses means it's not included, and I'm going to use -3 again as my starting point. This is positive. This is decreasing. It has nothing to do with being positive. So positive. Right when I hit this point right here, that's neutral, and that's +3, so it's neither positive or negative. Parentheses do not include it. Union, start back at 3. This one heads towards +infinity. So be careful there, okay? That one's a tough one. And this one is just like the previous problems. What is f of 0? So when x is 0, what's y? So I go over here, x is 0. Don't touch the graph here, but when I go up, hits it right there at positive 3. So y is equal to 3. This other one, f of x equals 0. So they're telling me that y is 0. What's x? So here I just go through, draw my line, and notice this one just happens to hit 2 as well. It hits at negative 3 and positive 3. And hopefully, if you can recall from the previous problem, those are the x-intercepts. So if you wrote that as negative 3, 0, 3, 0, you would see the x-intercepts. All right, last problem here. On what intervals is this graph constant? So that means from left to right, it does not change. As x increases, y does not change. So the only value I see where it's like that is right there. So it starts at 6, and it heads towards, with respect to the x-axis, infinity, and parentheses for both of those. On what intervals of x is f of x negative? So where on this graph is it below the x-axis? Well, it's below from here to here, open circle because that's neutral. This part right here is positive, positive, positive. At this point right here, it's neutral and it goes to negative. So this is negative infinity to negative 2, parentheses, union. This is 4 to infinity. All right. And now these last ones, obviously you kind of, hopefully you got the gist of it already. F of 0 is x. So I go up to here, I can see the y value is 2. And once again, that is the y-intercept. And this one, when it's 0, so notice it hits here at negative 2. Then it hits here at positive 4. And hopefully you can see that those are the x-intercepts. All right, if you have any questions, feel free to email me.